Hello students, my name is Goodluck Ayadi. I am your mathematics teacher for today, and the topic for discussion is approximation to decimal places. Happy listening. First, let us take a look at the objectives of today's lesson. Number 1, revision of place value system. 2, rounding up and rounding down numbers. 3, approximation to decimal places. 4, examples. 5, using the calculator for approximation to decimal places. So let us move to the first objective, which is the place value system. The concept of place value system is something you have been taught from primary school days. It forms the basis or the foundation of your mathematical knowledge. Now let us take a look at the number we have here. The number is 2457.938. Every digit in this number has its own place value as highlighted below. 2000s, 400s, 5 tenths, 7 units, 9 tenths, 300ths, and 8 thousandths. The number is divided into two parts, that is, the digits to the left hand side of the decimal point and the digits to the right hand side of the decimal point. Those on the left hand side form the whole number part of the number, and those on the right hand side form the decimal part of the number. Next, we have rounding up and rounding down numbers. Rounding up and rounding down numbers is very important in the concept of approximation because it eventually determines our final solution. Digits 0 to 4 are rounded down, that is 0, 1, 2, 3, and 4, which means they become 0. The final solution, or what we call the final approximated answer, remains unchanged. On the other hand, digits 5 to 9 are rounded up. That is digits 5, 6, 7, 8, and 9. What this means is that they become 1. And that 1 is added to the last digit of the approximated solution, which means the last digit increases by 1. Next, we shall be looking at decimal places. Approximation to decimal places, DP, is concerned with digits after the decimal point, that is, the digits to the right hand side of the decimal point, or what we call the decimal part of the number. Approximation to decimal places is very important because there are times when we have numbers to infinite decimal places. In cases where we have recurring decimals and the likes, or decimal places that have several digits. For example, 10 divided by 3 gives us 3.33333 to infinity. We need to shorten these to a reasonable number of decimal places. In some cases, the number of decimal places is given in the question or exercise. So if we give our result as 3.33, it means we have approximated to 2 decimal places. Mind you, we also have approximation that have to do with the whole number part of a given number. For example, approximations to nearest tens, nearest hundreds, nearest thousands, etc. affect not just the decimal part of the number, but also the whole number. In fact, the decimal part is completely wiped off. Please stay tuned. I'll be right back. Welcome back, everyone. Now let's take a look at some topics that require approximation. When solving questions, you may have come across instructions that require you to leave your answers to a number of decimal places. This is common in topics like area and volume of shapes, equations, geometry, and so on. Mind you, you are required to first get your accurate answer before approximating to the given number of decimal places. This takes us to subjects that require approximation. They include physics, chemistry, accounting, economics, among others. There are times when you have values that with large number of decimal places, and you need to bring it down to a reasonable size. To do that, the knowledge of approximation to decimal places is very necessary. Let us take accounting for instance. Financial calculations require you to leave your final answers to 2 decimal places, which represents the kobo. However, the subject with the greatest need for approximation is mathematics. In fact, approximation in other subjects requires the knowledge of approximation in mathematics to succeed. Now to the big one, approximation to n decimal places. Approximation to n decimal places means the result should have n number of digits after the decimal point. So, approximation to 2 decimal places means you need 2 digits after the decimal point, and same, approximation to 3 decimal places means your result should have 3 digits after the decimal point. Now let us take a look at some examples. The first example says, approximate 23.4571 to 1 decimal place, 2 decimal places, 3 decimal places. Now let us take this one after the other. To 1 decimal place, it means we need 1 digit after the decimal point. Now recall that the number of decimal places determines the number of digits after the decimal point. So which means 23.4571 will be equal to 23 point, the first digit after the decimal point is 4. But before we write that down, the digit after 4 is 5. All right, which means we round up, it becomes 1. And that 1 is added to the 4. The final result then is 23.5. Now, number 2 decimal places. We have 23.4571 to 2 decimal places. The 2 digits are 4 and 5. Now, the digit after 5 is 7, which means we round up. And it becomes 1, which is then added to 5. So our result is 23.46. The third one, which is to 3 decimal places, we have 23.4571, which means we need 4, 5, and 7. Now, 1 is less than 5, which means we round down. So our final result remains 23.457. Let us go on a short break. We will look at another example when we get back. Please stay tuned. Welcome back, dear students. So let us take a look at another example. Approximate 48.935 to 2 decimal places. So 2 decimal places means we require digits 9 and 3. Digit 5 is the third decimal place. But before we let go, 5 is rounded up, which becomes 1, and that 1 is added to 3. So our final solution is 48.94 to 2 decimal places. Moving on, we're going to learn how to use the calculator to do our approximation to decimal places. And in this case, our reference material is the Casio FX82MS second edition. In order to do this accurately, you need your mode button, which is on your scientific calculator. Now, the mode button helps you to move from one major mathematical concept to the other. In the case of approximation to decimal places, you need the fix mode. Now, let us take a look at this example, which we shall solve using our previous method and then using our calculator. The example reads, approximate 526.8347 to 3 decimal places. This means that we need 3 digits after the decimal point. So as we have done before, the 3 digits are 8, 3, and 4. However, 7 is greater than 5, which means we round up. It becomes 1, and that 1 is added to 4, which means our final solution is 526.835. Now, using the calculator, as I mentioned earlier, we set our mode to fix. The next thing, you need to enter the number of decimal places you wish to approximate. This process ensures that every calculation that you carry out on that calculator gives the results to the number of decimal places that you have selected. In this case, our number of decimal places is 3. So on the calculator, after setting it to 3 decimal places, we enter our number, which is 526.8347, and then we click on equals to. Automatically, it gives us our answer to 3 decimal places, that is 526.835. Now you can imagine if you're doing financial transactions that require you to have your results in 2 decimal places. Once it is set on your calculator, every calculation gives you your answer to 2 decimal places. Thank you so much for being a part of this class today. I look forward to having you in my next class. Bye.